Alright. So for the third problem, we have we're finding the volume of the solid generated by revolving the region bounded by the graph about the x equals 1. Here, this is the graph they give us. They give us the functions here. Notably, they're y equals. So just right off the top of your head, you should know, or at least I should know, that we're dealing with delta x, not delta y. So if anything, it's going to be rotating this way. So I want to start off by drawing a little strip. A little strip here. Calling it delta x. Delta x. The first thing I want to do when approaching this problem, or for me either way, is finding the intersection points. We are finding the area bounded by these two graphs, so notably we have to find the intersection points. So we're given the two functions, y equals 6 minus 2x minus x squared, and y equals x plus 6. Visually, what I can understand is only one of them is a quadratic, so its power is to the second, x equals negative x squared. Another one only has x. There you go. So notably, this would be more of a parabola shape, and this would be a linear function. So the only linear function I see here is straight line is the bottom one right here. So I would assume that would be y equals x plus 6. And the top function here would be 6 minus 2x minus x squared. So we're in the shape of a parabola. If you extend it a little further, you get a better visual of a parabola. Get a better visual. So in order to find the intersection points, you want to equal the two functions. So we get 6 minus 2x minus x squared. We have to equal that to the other function, x plus 6. Notably, the point of finding the intersection points is to inevitably find our bounds of integration. So whatever these points are here is also double for our bounds of integration later on. So this is just simple algebraic manipulation. I like to keep the negatives positive, and in order to do that, and move it over to the right, even though it looks simpler to move it to the left. So we just add x squared, add 2x minus 6, simple, let's move it over, x squared plus 2x plus x plus 6 minus 6, and just simplify it out. The simplification of it would just be x squared is equal to 3x. Right. This would be now equals 0. Both sides. So for this, just factor out an x. 0 is equal to x plus, and then factor that out. Here, notably, we can see in order to make this statement true, it actually equal to 0. This x would have to equal 0 in order to get whatever's in the parentheses to 0. We'd have to do the negative 3. So x could either be 0 or x can equal negative 3. Only two x's that would make this statement true. Alright. So now that we have this, we are going to be rotating this about the x equals 1. Right? So we know this point here is negative 3, is 0, I guess. Somewhere around this area here. Be 1. Right? So we're going to be rotating across this. Since we are rotating across the x equals 1, it's going to be making more of a shell. type figure. So we know we're dealing with a shell problem. So it looks kind of messy there. I'll have to take it out so we can get a better look at what the shape looks like. The shell. Poorly drawn shell. So what we know about the shell is, one, the height. The height would be the top function minus the bottom function, the strip here. So as we identified earlier, the top function would be the quadratic, the 6 minus 2x minus x squared. And the bottom function would be y equals x plus 6. In order to find the area or the height between these two, you have to subtract them, top function minus the bottom function. So we'd be getting 6 minus 2x minus x squared minus bottom function x plus 6. That's the height here. And for the circumference, we know that the distance here from 1 to whatever this is going to be is x. Whatever this arbitrary x is going to be. We know the right side minus the left, the right x minus the left is going to be the length of the radius for the circumference. Yeah, let me explain that better. Formula for the circumference is 2 pi r. If we can identify the r, it would be 1 minus the x, in this case. The right x minus the left x, that'd be 1 minus x for our r. Place that. 2 pi 1 minus x. And that would be circumference. For the actual thickness of this cylinder, since it is a 3D shape, it's best to visualize it as a rectangle. Just split it down the middle, anywhere down the cylinder. You get a better visual of what it actually should look like opened. The thickness of this little rectangle would actually be delta x. It's just a little thickness, because this actually is a little thick, even though it's a really small, arbitrarily small number. We just call it delta x. Circumference would be 2 pi 1 minus x, which also doubles as the width. And the height, as we said here, would be the quadratic minus the linear function, top minus the bottom y. So in order to actually find the volume of the strip, you take all these into consideration. Finding the area of a rectangle, which is base times width times height, like length times width times height. So in order to label this, we have the height, we have the width, which is the circumference, the length, the thickness. In this case would just be delta x. Writing this function out. Volume of the strip would just equal circumference times the height times the thickness. Alright, so let's plug everything that we know into this volume for the strip. So we get the height, which is 6 minus 2x minus x squared minus x plus 6 times the circumference, 2 pi 1 minus x and delta x. Add a delta x here. Not enough room. So that would be the volume of the little strip, just one strip. But we're not worried about one strip, we're worried about the whole function itself. In order to do that, we're going to have to integrate. The total volume would be an integration, and our bounds of integration would actually be the intersections that we found earlier, the 0, -3, starting from the left, which is -3, to the right, which is 0. We're doing this because we want to find the area in between these two functions and they're all bounded by their x's. Explain it. So when we integrate this, we integrate the function down here, which is going to be the same. 6 minus 2x minus x squared minus x plus 6 times 2 pi 1 minus x. And since we're integrating, this delta x here is not going to be a delta x anymore. It's going to turn into a dx. So since I'm running out of room here, I'm just going to switch over to another piece of paper. I'm just going to bring down what I wrote up top down. Volume total equal 0, -3, 6 minus 2x minus x squared minus x plus 6 times 2 pi 1 minus x dx. And to explain how we got here again, we had to find the height of the shell, which is the top function, minus the bottom function. We had to find the width of this rectangle, width of the circumference of the shell in case, same thing, which is 2 pi r. And we figured out that the radius of this cylinder would be 1 minus x, the right x minus the left x, 1 x. And we know that the thickness is delta x, infinitely small. So I guess we can label it. This would be the height, this would be length, this would be the thickness. Now we just have to integrate it now that we have our integration. First thing I would do is, one, take out the 2 pi. That's just a constant that's going to just come along for the ride. And then simplify this whole mess here. So volume total equal to 2 pi. Again, it's just a constant, so you can be taken out. Distribute it over this negative, minus x minus 6. This all simplifies to this here, which simplified to minus x 6 minus 2x minus x squared minus x minus 6 times 2 pi. I don't want the 2 pi that anymore. So 1 minus x delta x. Simplifies even further. This all goes away. The 6's cancel out. Minus x and minus 2x. Add those together. Minus 3x, and then carry down the negative x squared. You still have the 1 minus x still being multiplied and the dx. So now you can just distribute either this into that, this into that. Your preference. I'll distribute this into here. So -3, 0, 2 pi. So 1 times negative 3x is just negative 3x. 1 times negative x squared is just negative x squared. x squared. Negative x times negative 3x positive 3x squared. And negative x times negative x cubed. X squared is going to be x cubed. Negative times a negative, positive. Power 1 basically. Just add them together. Make a third. Alright. I like to keep all the positives first. Alright, so I'm going to rewrite this and bind like any like terms that we have. So it's x to the third. We have these two like terms here. So it's 3 minus the 1 would just be plus 2x squared, and then bring down the negative 3x. So that's the simplified version of this, of 1 minus x times all this mess over here. Now that we have this, we can simply integrate. And bring down 2 pi as well. So when integrating this, you just one by one go down the line. X, just power, reverse power rule. X to the fourth divided by 4. Bring the power up by 1 and then divide by the new power. X plus 1 is x cubed divided by the new power minus 3x squared divided by the new power. All this is still going to be from negative 3 to 0. Alright. I'm going to need another paper. Again, just going to be rewriting from where we left off on top. We integrated. X over 4 plus 3x to the third minus 3x squared 2, 0, negative 3. So one thing I want to mention here is just plugging in 0 here, just cancel out everything, 0 everything, everything to 0 to the anything power is going to just 0 out the whole thing. When you plug in the negative 3 though, you're just going to basically take the negative of what you get from putting in negative 3. So I guess one way of explaining this is you're going to have whatever this is, the 0 when you plug in 0, minus whatever you get when you plug in the negative 3. Right? So since we know this is just going to 0 out, this is going to 0 out, it's going to be we're just going to put a negative in front of whatever we get from here. So we're just distributing the negative over whatever our final answer is here. So there's no real point of plugging in the 0 because it's going to just be 0 everything. So we're going to show negative 3 power 4 over 4 plus 2 times negative 3 the third 3 minus 3 negative 3 squared over 2. So figure this out, negative 3 to the power 4, it's going to be negative 81 over 4. Make sure to consistently bring down the 2 pi, because if you forget that, then you don't have the right answer. Negative 3 to the power of 3. Negative 20. Negative 27. Negative 27 times 2. 2 times negative 27. Note that this is an odd power. So the negative is going to stay a negative, unlike this one where it's an even power. Alright. Over 3 minus -3 squared. It's 9. 9 over 2. Alright, simplify all this. To simplify this, and then to simplify that, it would just be -81 over 4 plus, what was it, 27 times 2, 50, 54. If my math doesn't fail me, that is 54 over 3. Alright. Minus 9 times 3 is equal to 27. 27 over 2. Oh, I found a mistake. Found a mistake. -3 to the power 4 is a positive 81. Positive 81. Right? Because any negative number to the even power is going to be positive. Any negative to the odd power is going to be negative. Stay negative. So that'll be 81 over 4 plus -54 over 3 minus 27 over 2. But we can't forget this little negative sign that we said we were going to distribute over. This little negative. But really, this whole whatever's in parentheses, -3, this is what we actually have. So we got to distribute over the negative. So this little 81 turns to negative again. -81. This -54 going to turn positive. Plus 54 over 3. It's -27 over 2 is going to turn positive. So that's 27 over 2. I just got to add all this up. So just common denominator. I want to find a common denominator. I guess it'd just be best to simplify this 54 over 3 first. 54 divided by 3 is just equal to 18. You can go ahead and rewrite that. Plus 18 plus 27 over 2. Simplify as you can get. Common denominator, put everything under 4. -81 under 4 plus, if we put this under 4, we got to multiply the, that's equals 18 over 1. So we just, what do we do at the bottom? We do at the top, elementary. So 18 times 4 is going to equal 54 over 4. And then we got to multiply this times 2 to have a common denominator. That equals what? 27 times 2 is 54. My math is wrong again on this one. That is not 54. 18 times 4 is 72. He's recording me again. Simple algebraic
I want to get the TV cutting out.
Oh. Alright. So again, a simple algebraic mistake here. Luckily we caught it again. 18 times 4 is of course not 54. It's 72. Alright. So what happens when you get used to using a calculator and you're not used to doing it in your head anymore. So let's clean this mess up again. Work that way here. bring everything down again. So 2 pi negative 81 over 4 plus 72 over 4 plus 54 over 4. Right, so add up all these numbers, negative 81 plus 72, then add 54. Some basic additions here. Hopefully my addition doesn't fail me. That will equal 90, 45. Fuck up. I added wrong again. Alright, so let's just bring everything down, clean everything up. Kind of looks a little messy here. So 2 pi negative 81 over 4 plus 72 over 4 plus 54 over 4. Alright, so we add this up. We add it all up. We will get 45 over 4. 81 plus 72. Math. Get what? Negative 9. 54 minus 9. Negative 81 plus 72 is negative 9. Negative 9 plus 54. 54 minus 9. It's going to equal 45. 45 over 4. Right? We can't forget the little 2 pi over here. Take out 2 pi times 45. 90 pi over 4. To simplify that down even further, it's just 45 over 2 pi. Well, that would be the volume for the total area, total volume. Sounds about right. 45 pi over 2. Have a pi there. My solution for it. Something like that. Oh. Oh. Wings. There you go. That's our answer.